Hello everyone, welcome to Physics Challenge. Let's look at this problem, which is a fairly simple one. So here is a disk on a frictionless surface, horizontal surface, and then there's a constant force T acting on the edge of the disk. So it's pulling the disk. The disk is spinning and accelerating. So we know the momentum inertia of the disk, the mass of the disk, and the radius of the disk. Assume the disk is accelerating for a while, say at time t. What is the total kinetic energy? Note that in this case, the force is not acting on the center of the mass, which means the total kinetic energy is decomposed into two components. The first component is the translational kinetic energy, and the second component is the rotational kinetic energy. So for the first component, the translational kinetic energy, we can treat the force as if the force is acting on the center of the mass. Then everything becomes easy. We can use the fundamental law we know, F equals ma, and find that the velocity is actually t times t over m. The translational kinetic energy becomes t squared over 2m. So for rotational kinetic energy, since the force is acting on the verge, on the edge of the disk, so the disk is actually spinning. While it's spinning, the force in this case is actually the torque. Then we use another version of the Newton's law, which is tau equals I times alpha. And alpha is the acceleration of the angular velocity omega. So we can also write it as I times omega prime, which is the first derivative of the angular velocity. And the torque in this case is obviously RT. And then we find omega is RTT over I. So the rotational kinetic energy is 1 over 2 I omega squared, and equals R squared T squared lowercase t squared over 2I. And then the total kinetic energy is therefore the sum of the translational kinetic energy and the rotational kinetic energy. So the problem is fairly simple, but the idea is very principal, and it's a fundamental law in physics. So whenever we are dealing with kinetic energy, we always want to look for translational kinetic energy and rotational kinetic energy in general cases. So I hope you enjoyed the content. If you liked the video, please like, subscribe, and comment below. See you next time.